Hey everybody, welcome back to Practical Alchemy. Today I'm going to be taking you through part 4 of our beginner's guide to Fusion 360. And today our main concept that we're going to be talking about is the Revolve feature, and that's going to help us to create some more complex rounded geometry. We're also going to be talking about how to create construction planes, and I'm going to show you a few different tools for referencing existing geometry. So let's jump in. The last thing that we did at the end of our last tutorial was to pattern our brick, and we really don't need that. So we can go back and delete that second brick. And to be honest, we are pretty much done with this 3x2 stud that we've created in our past tutorials. Now, we're not going to delete him. We are still going to stay on the construction brick theme, but in order to help us create our rounded shapes, we're not necessarily going to do a bunch of extrusions. That seems like it's kind of tedious and time consuming. What we're going to do instead is use our Revolve command. And as you may think, or as you may assume from the description, the Revolve command acts similarly to the extrude command in that you are taking a flat profile sketch and you are rotating it around a axis. And so what we need to do is create that profile. So what we're going to do is we are going to create a 1x1 cylindrical stud. And in order to create that sketch, we want to sketch over one of our existing studs. Now, we've used a few different planes so far. I'm going to turn this brick off really fast. I'm going to turn on our reference geometry. So far we've used the standard kind of origin, baseline, XY, YZ, ZX planes. And we've also used surfaces of our body as planes for sketching. Sometimes you are, in fact, oftentimes you are going to need additional planes in other places to create your sketches. So rather than referencing geometry to create those sketches, we can offset them or somehow reference them to existing sketches. So let's go over here. Those planes are going to be under the construction tab. So if I click here, you can see there are a lot of different options. The one that I'm going to show you today is the one that I use most often, and that is the offset plane. So essentially we're defining this plane based off of an existing plane and offsetting it by a certain distance. So in the dropdown, it's going to ask me for a plane. All right. And so that is going to define the majority of the information that the program needs to create this plane. So this is the plane that I'm referencing. I already know its YZ orientation. Really, all I need to know is how far off from this plane in the X direction I want it to be set. All right. Now, I could extend it just a set distance, but as you've learned by now, when we are building off of existing geometry, it's always good to go back and reference existing geometry. So if I want this plane to be in the center of an existing stud, because that's what I'm going to be revolving around, I want to set this plane in the center of that stud. And what I'm going to use here, there's a lot of different things that we could use, but what I'm going to use here is my initial peg sketch, all right? And I am going to select this center point. So down on the existing options, I'm going to go to Object. I'm going to select this origin point. All right. And if you see I rotate to get a better view, I am hitting that center point or intersecting that center point. You can also do an offset from that. So when it says 2 here, you can actually do an offset distance. I'm going to hit OK. And as you can see, there is now a new option here called Construction in the drop-down browser. This is plane 1, and I am going to just rename this the peg plane. Okay, great. So now that we have a plane here, I'm going to turn off the other reference geometry just to clean up the space a little bit. And I am going to create a sketch in that space. All right, so I'm going to go in here and I am going to create sketch. All right, so now that I'm in this sketch, there are a few things that I want to create. The most important thing to create when you're going to create a revolve is the center line of the revolve. So I know where the center line is going to be, and I want to actually reference, again, this existing sketch. So I can come in here, go down to Project. We've done this a few times, and I can select just that center point and hit OK. All right, so now I'm going to turn off the peg sketch just so I don't get confused. And you can see that I now have the center point from that peg that I can use as a reference point. From there, I'm going to create a line. The distance actually does not matter. It could be infinite. You could define it if you want, but for our cases, we don't actually really need to define it. And now I'm going to come over here to the options panel, and I'm going to convert this to a center line. All right, great. So now we are starting to come together and create our peg. All right, next up, we want to create this existing peg, or this 1x1 peg, and we want it to nest and lock into these existing pegs. So I'm going to slow down for just a sec and explain. In this example, we are going to be referencing geometry that already exists. There's no reason for us to go back and manually type in all the different dimensions. I could, right? So for example, I could have a sheet of paper where I'm just going to sketch a line here just for illustration purposes. We're going to delete this so you don't have to do this. So I can come in here. I can create this geometry that's like my peg. Okay. And I can go in and manually dimension this. I know what the dimension... this is actually a good opportunity to show you something, though. If you're going to dimension across a center line, if you select the center line and the vertical, and you drag your mouse across, it will allow you to do the diameter, not just the radius, right? So you could do the dimension across. So I could say, well, this peg is going to be 25 millimeters across, and this one is going to be 30 millimeters. I could do that, but it's fairly inefficient. In fact, it's very inefficient. And the other problem that you're going to have here is as your model gets more complex, if I, for example, go back and change the diameter of this peg, I am going to then have to try to go back through this timeline and figure out where I made those changes. And I'm actually going to have to do that peg again. It's very time consuming. All right, so the next thing, so instead of doing that, what I'm going to do is I'm going to pull some existing geometry off of this model so that I can use it as a reference. All right, this is going to be a little confusing, or it may be a little confusing, but I'll try to go slow so we can walk through it. All right, so what do I know about the pegs? Well, I know all of my pegs are going to be the same height, and I know all of my pegs are going to be the same diameter. And I know that the overall body length is also going to be the same. So I'm going to pull those dimensions. We are running into a little bit of a problem here, though. And this is good because this gives me an opportunity to talk to you about order of operations. Let me show you something. If I, for example, come in here and I pull all of these sketches that I want to reference, right? And I'm going to create some projected geometry. This is good, but it's also capturing the data from all of these fillets that I've created here. Now, the reason why I don't necessarily want to capture all of those is because similar to me changing the size of the pegs or anything else, if I go back and make changes to those fillets, those won't necessarily be captured. So generally speaking, as a rule, you want to create all of your major geometry before you start filleting things, all right? The nice thing here is that we can actually go through our timeline. I'm going to finish this sketch, and I can go through. I know where all of these fillets are. They don't reference anything else, so I can scrub them forward in my timeline. Whoop, excuse me. I'm actually going to pull my offset plane back before I did my fillets. All right. I'm going to scrub these back in the timeline to before I did the fillets, and I'm going to scrub back in my timeline to suppress those fillets so that I can now pull some of this more native geometry. All right, and I'm going to edit this sketch. Okay, so I went back a little bit too far in my sketch pull and lost that center point that I had, but that is okay. We don't really need it. So let's go and start grabbing some reference geometry. We are going to project, and we are going to include this peg here, and this peg here. And we are going to hit, oops, sorry, I did not create the project command. So we're going to project, and we are going to select this geometry, this geometry, this geometry, so I know where the top edge is, and hit OK. All right, now, and I'm going to go back to my side view so that you can see what's happening. All right, I'm going to turn the body off, and you can see that we did not capture the vertical uprights, and that's okay. We don't really need them for this example. We can just use this, and we'll convert all of this to sketch geometry or construction geometry, and we are good to go. All right, now, let's start building that cross-section for our Revolves profile. So first thing I'm going to do is I'm going to create a center line, and you can see I could create a center point, but I know where the midpoint of this top is, so I'm going to use that as my revolution axes. All right, I'm going to turn that into a center line, and now I'm going to turn the brick back on for a second, so it'll help us visualize the shape. Okay, so what do I need to build my brick? And I'm going to just do this with the line tool. So I need the top of my peg. I need kind of the main boss of the peg. And I need the kind of outer surface of the peg. And as you can see, I'm letting all of these snap to a 90-degree angle because I want to make sure that I can strain all of them. All right, and I'm not going to drag it all the way down to this line. I am going to go over. And this is another great thing, is if you have lines where you want them to connect, but they're not long enough, if you hover over it and then slowly drag down, it will still capture the tangent to that line. So I'll capture there, and then I'm going to close it up. All right, great. And I can go ahead and just turn this into construction geometry because I really don't. Turn that back off. Never mind, because it turned not blue. Okay, so what do I know? Well, I know that the length of this peg and the length of this peg are going to be the same. So I'm going to click on both and click on the equal sign to keep them at the same length. I also know that this line, shift, and this line are the same. So I'm going to make sure that they are equal. I also know that these two pegs should share the same diameter. And so I'm going to actually show you a new constraint that we haven't used yet. Click this line and this. Kind of hard to grab it. Oh, I don't have a line on that side. Just going to drop a quick construction line here. Zoom back out. This line and this line need to be what is called collinear. All right, so essentially they are on the same linear path. So they are locked either vertically, horizontally, or at any specific angle, as long as they would, if you were to draw a straight line between them, they would be the same line, essentially. Different CAD programs approach that differently. Programs like Onshape just use the coincident constraint for that, which is a little bit different. Makes sense when you think about it, but it's a little bit hard to get used to. All right, so the next thing that I know is the overall length. Ooh, all right, so now it's getting tricky. So what do I know the outer diameter of this to be? Well, actually, I'm going to grab one more line for my projection to understand this. So let's go and grab the projection tool, and I'm going to grab the top of this line. All right, and I'm going to show you what I'm going to do. Basically, I know that it's going to be half of the distance minus the manufacturing tolerance that I want to make sure that they're not actually touching. Okay, so this will make sense, but I'm going to create a line in between them. All right, drag this out of the way, turn this into construction geometry, create a point at the midpoint. All right, and now I'm just going to dimension this based off of my manufacturing tolerance, which in this case, because this would be a sliding fit, it would be 0.5, so half of that would be 0.25 millimeters. All right, so you can imagine think about it, if this was mirrored across, there'd be one peg here and one peg here, so you need to make sure that they don't touch each other. All right, so that's what I've done there. Now, the last dimension here, this is the outer edge of this peg. All right, let's rotate to understand what we're doing here. We're capturing the outer edge of this peg. What does this need to do in the nature of a construction brick? Well, if I was using a single peg, it should also be able to fit here. All right, and I have an object already in existence that fits that requirement, and that is this circle here. So one last time, I'm going to create a projection, select this edge, hit OK. All right, turn it into construction geometry. And now I'm going to need a little bit more information here. All right, which is I don't know this line. So, all right, how are we going to do that? How are we going to think about these as the same length? So if I go back in and I delete this line, all right, I can grab and create a new line. I'm going to put in the midpoint. All right, I'm going to constrain the midpoint coincident to my center line, and then I'm going to connect these 2 points together. So now I know that as this stretches, it is going to go stretch across the center line. So now I can select this line, and I can select this line, and I can create these to be equal. All right, cool. And I have a closed profile. There's still a few things that I'm missing though, aren't I? All right, so these are basically my offsets here. So I know that all of these want to basically touch, but not interfere. All right, so I'm going to make this sit. I'm going to turn the peg back on just so you can see it a little bit better. All right, so I'm going to manually put in 0.5 millimeters, which is my offset. Same thing here. I want this surface to touch the top of the pegs, but not intersect with them. So another 0.5 here. And now everything is black. Everything is fully constrained. And the only things that I've put in here dimensionally are the offsets. Now you may be thinking, well, even this is a little bit complicated in terms of doing all of these reference dimensions. Surely there must be a better way, and there is, and that is by defining variables, which I will show you in a later tutorial. But for now, this is a good example, especially as you're starting out, of understanding the thinking of how you're making sure that new geometry is referencing old geometry so that as you update things and as you change things, the model won't break down and you don't have to go back and dimension every single sketch. Look at how many sketches we've got at this point, right? Even in this very simple model, we've got a lot of sketches that we would have to go back through, figure out what we dimensioned where. So the fewer dimensions that you can have in your actual model, the better. All right, let's finish this sketch and let's do a revolve. First, we are going to hit save. All right, hit save. And now let's do the revolve. So click on the revolve command here. It is going to ask me for the profile, and it has automatically selected the axis because there was a center line in my sketch. All right, here you can see there are some additional options in the dialog box. This is the angle. Or if you want to go to a certain object, same as how we did with the extruded command, you could do that. You can set the angle. Maybe I only want it to be half a circle. Or maybe I want to be two-sided and I want to go 180 degrees on one side and 25 degrees on the other side. You can see that little addition there. And I can create a cut operation. I can use it as a join. In this case, I'm going to do a single 360 degree profile, and I want this to be a new body. Okay, now we have our 1x1 peg. Let's go ahead and rename this. Very cool. Now, what do we need to do next? Well, I want to show you a new command for creating hollowed out geometry, and that is the shell command. All right, this is a really, really cool and really useful command. So when I click on the shell command, what it's going to ask me are the faces of the bodies. So which faces do I want to exclude from the shell operation? Okay, which I'm actually going to just make sure I collect the right thing. Select this bottom face, and then the thickness, whether it be the inside, outside, or potentially both. All right, so if I remember correctly, I believe this was a 3mm model. Wouldn't have to remember if I had a set of variables, but I did not. So we're going to say this was 3mm thick, and I'm going to hit OK. What did that do? That basically created a wall that is 3mm thick. It's very hard to see. So let's go up into the inspection panel here. We are going to create a section analysis. We'll use this plane here. And it's like, well, where is it? Well, and I need to change the distance here. All right, and you can see that we have now hollowed out this entire body, and it's going to do its best to maintain a 3mm wall thickness throughout. The reason that I say it's going to try to do its best is because while the shell command is very useful, it also is it breaks down, especially as your model gets more complex. So if you try to incorporate all those very small radiuses, sometimes it'll fail. It's not perfect. It's basically doing a good job of approximating what we were trying to do with all of our manual cutting here. Sometimes it's great, sometimes it's not. Sometimes you still have to go back and make additional changes afterward, like we're going to have to do here, which is, as you can see, our peg is intersecting with our geometry. All right. So how do we fix this? The top of our peg is good. The bottom of our peg does not accept our peg. So how are we going to do this? Well, we're going to go to this analysis tab that's new, and I'm going to hide this section view. All right. And so what we need to do is we need to create another cut that includes all of this additional geometry. Now, for the sake of this example, I'm actually going to slide forward to the end of our timeline here to recapture these fillets and radiuses, because now I do want to show you something about these fillets and radiuses. So I'm going to use this same peg plane, and I'm going to create a new sketch. All right. Now, for this example, because I want to hollow out the inside of this peg using this final shape, I want to just copy this geometry. Now, if I go here and go to the project command, and I select this geometry and hit OK. As you can see, it did not capture the actual fillets, which, for our original example was fine if it didn't capture the side walls of these rounded objects. But for this example, I do need it to capture those things. So there's another very similar command to the projection command. In fact, they're sitting right next to each other in the drop-down menu, or they're under the same drop-down menu, which is the intersection command. So what this is going to do is it's going to essentially create a 2D line drawing version, for lack of a better example, of the 3D geometry. Okay, so I'm going to click these two objects here, hit OK, and it is going to project this 3D geometry with all of its edges onto this 2D plane. All right, so you can see now I've got these edges here, which is what I really want to capture. And so I'm going to turn this back on, and I don't want this to be overly busy, so I'm just going to put these in really quickly rather than adding another command. All right, we do need a center line, so let's go ahead and place a point in the midpoint, drag it up, and turn this into a center line. All right, so now we could just use the edge of this surface. I'm just going to turn these bodies back on for a second. I'm going to change my display mode to, just for a second, wireframe with visible hidden edges. I could just cut around this exact object, but I want to do an offset so that it can actually fit together. All right, so I'm going to turn my peg off. I'm going to go back to the standard shaded with visible edges plane. I'm going to turn the brick off now. And now let's do an offset. So we're going to do an offset all the way around, selecting the geometry as we go. And make sure it's on the right side. Negative 0.4. Okay, great. and I'm going to hit OK. Perfect, perfect, perfect. Now, looks like we've got some closed geometry here. So let's turn our peg back on. We are going to finish our sketch. Everything is black, so it's fully constrained. That's great. And we're going to create a new revolve. We are going to select the profiles. And we are going to turn this profile crosses the revolve axis. Oh, silly me. Okay, let's go back. So basically what it needs is it needs a break line here to kind of figure out where this is all crossing the axis. So pretty simple fix. And, you know, I will say the error messages in Fusion are generally pretty good and pretty descriptive. When you go back to some of the older CAD programs like, well, you don't know what Pro is, right? But there's like the dialog boxes are just so confusing, and you'd have to go literally like 18 help menus, in my opinion, or maybe I was just young, to figure out what it even meant. All right, so let's finish the sketch, and we are going to go back to Revolve. We are going to select this profile now, which makes the CAD program happy. We are going to cut. The objects to cut are the 1x1 peg. We're going to hit OK. And, oops, I must have not included something in my sketch profile here. Edit feature. Ah, there it is. Forgot the middle part of this profile. Hit OK. And now you can see that we have a very nice interior peg. Let's turn the 3x2 brick back on. We're going to turn our section view back on so we can see the analysis. And as you can see, we've got a really nice hollowed out peg there. So that's it. That is Revolves. Let's turn this section view back off. It's really cool. We can go ahead just really quickly, and we can add some fillets in. So what you could do, unfortunately, you can't scrub this at the back of the timeline, but we can go back in and we'll just fillet these very quickly just for show. I'm going to do a larger fillet than we did on the other pegs. That way it looks more like a head. So let's see, how big should we go if we want it to be a head? Hit OK. And we'll do a nice little top fillet here. Just drag it manually because we're going to change it later on. Oopsies. There we go. And that is looking pretty cool. So we have got our nice shelled out and revolved 1x1 peg ready to go. And that is it for today. So I hope you enjoyed this tutorial. Thank you so much for watching. I hope it has helped you to better understand the tools available to you in Fusion 360. If you like this video, hit the like button. If you have any questions or comments, please leave those in the comments section. I will try to answer them. And if there's any topics that you would like me to discuss specifically, please put those in the comments section as well. It gives me great inspiration for future videos. And if you want to follow along with other videos as they're produced, please subscribe. It really helps out the channel. And with that, I'll see you in the next one.